That is a great question for an amateur radio operator. The length of a half-wave dipole antenna, which is what an inverted V is based on, is primarily determined by the frequency and the velocity factor of the wire. For your specific antenna design, frequency 7135 kHz or 7.135 MHz. Wire 2.5 square millimeter insulated copper wire, likely PVC or similar insulation. The insulation on the copper wire slows down the radio wave, which is accounted for by the velocity factor. For bare copper wire, the velocity factor is very close to 1 or about 0.95 to 0.98. For PVC insulated hookup or house wire, the velocity factor is typically lower, often falling in the range of 0.93 to 0.97. I will use a standard conservative value of 0.95 for insulated wire for this calculation. You may need to fine-tune this by trimming the antenna once it is installed. Formula for the total physical length of a half-wave dipole antenna in feet is 468 divided by frequency in megahertz into velocity factor, and in meters it is 142.5 divided by frequency in megahertz multiplied by velocity factor. So for 7135 kHz with a velocity factor of 0.95, the length in meters will be 142.5 divided by 7.135 into 95. That will be 19.97 into 0.95. So it will come to finally 18.97 meters. An inverted V antenna is a half-wave dipole antenna bent at the center. The total length is the same as a horizontal dipole, but it's typically cut into two equal halves. Total antenna length 18.97 meters. Length of each leg 18.97 by 2, approximately 9.485 meters. The calculated length is a great starting point, but the final most accurate length is determined by your specific environment, height above ground, surrounding objects, type of insulation, etc. Cut the wire slightly longer than the calculated length. Example 19.5